Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 7, which is roots and radicals and functions. And today we're doing functions, basically domain restrictions and stuff, okay? So this is basically going to be... Oops, didn't mean to draw there. And it won't go away. There we go. So, we're basically talking about functions, and we're talking about the domain. Do you remember which one was the input, which one was the output? We had domain and range. What was the input? The input was the domain. So basically what we're talking about today, we're talking about compositions of functions and basically creating new functions from adding, subtracting, multiplying, or dividing functions. And the domain is basically what we can plug in. So when we're doing any kind of function, sometimes there's values where we can't plug in for x because it'll yield a problem. Like if you have 0 in the denominator or something, or if you have a negative under a radical. We did have imaginary numbers and stuff and complex numbers for that, but in this case with functions, when we have 0 in the denominator and we have negatives under a radical, under a even root, that is, that creates a problem. We can't actually graph it, or it's a problem with the function, okay? But today we're going to start with function operations. So basically we have, we're going to take f of x and g of x, and we're going to add, subtract, multiply, and divide them. And basically it's just going to create a new function. So let's get right into it here. So the two functions we have are f of x equals 3x minus 4 and g of x equals 5x. And our first operation we can do with function operations here is we can have h of x equals f of x plus g of x. All right, well, let's do it. So we're going to do h of x equals, well, f of x was 3x minus 4, so I'm literally going to write 3x minus 4. That's f of x. Plus, and then g of x was 5x. I'm going to put 5x. Okay? So we can add functions to come up with new functions, and that's what we're doing here. So let's go ahead and simplify this now. We have h of x. Well, if we combine like terms, 3x plus 5x is going to be 8x. And then the negative 4 is going to come along for the ride. So that is the new function. By adding those two previous functions, we came up with a new function, which is 8x minus 4. All right? Okay, if you want to see if you can try the other ones, we're doing subtraction, multiplication, and division. See if you can do them on your own, and then we'll go through them in a second. All right, the next one we have is subtraction. We have f of x minus g of x. So we're doing h of x. Well, f of x is still 3x minus 4. We're subtracting g of x, which is 5x, so minus 5x. And h of x is going to equal, well, we got to combine like terms here again. What is 3x minus 5x? That's a negative 2x. And the negative 4 is going to come along for the ride. And there's our new function. All right, next one we have is multiplication, multiplying f of x times g of x. So in this case, h of x, our new function, is going to equal f of x times g of x. Well, our f of x is 3x minus 4 still. I put parentheses around it because we're going to multiply 5x times 3x minus 4, but we need to be careful here. Remember, we need to do distribution. We need to multiply 5x times 3x and 5x times negative 4. So h of x is going to equal, 5x times 3x is what? That's going to be 15x squared. And negative 4 times 5x is negative 20x. All right, last one we have is division. Last one we have is division. This one we have to be careful because the denominator cannot be equal to 0. We can't divide by 0. So in this case, when we do f of x divided by g of x, we have to set g of x equal to 0 to figure out where it's going to be a problem. So let's go ahead and do that first of all. So we have h of x equals, f of x is still 3x minus 4, divided by g of x, which is 5x. And then I'm going to put a semicolon here. So now, the caveat, or the condition for this function is that the g of x cannot equal 0. So I'm literally going to take g of x, which is 5x in this case. I'm going to say 5x cannot equal 0, and then I'm going to solve for x. So how do I solve for x here? Well, I divide by 5 on both sides. So x cannot equal, what's 0 divided by 5? x cannot equal 0. So that's one extra step with division, that you have the denominator cannot be equal to 0. So just make sure that when you're doing that, that you're careful and you set the bottom equal to 0 and then you solve. So what's the domain of h of x? The domain is the x values. It's what you can plug in for h of x. And there's a couple things we need to be careful of, okay? A couple things we need to be careful of. We're going to write cannot have x value if, then we have two things down here. We'll put a line underneath here. If it makes the denominator equal to 0, like we talked about. Can't have the denominator equal to 0. We also, it can't make, or if it makes a negative number under a radical with an even root. Okay? So if we were to take some of these functions and graph them, if we plug in some of these values, you'll see that we'll have like a weird, like it's called an asymptote, is where the graph will basically kind of look like this. It'll be, so if we have a graph like this, it'll kind of go, it'll slope like this, and then it'll slope like this. So it'll be going like, basically there's no value here in the middle. You see how it goes up forever in this direction and goes down forever in that direction? There's actually no value there. It never like quite touches that value. So that's kind of what we mean by kind of a problem with the domain. Okay, it's when we have a value that we plug in and there's like no value that we can actually use. All right. So yeah, so we can't have a radical with an even root. And the reason for that is what's the cube root of -8? Well, that works, right? The cube root of -8 is -2. That's fine. But what's the square root of -4? Well, that's 2i, but we can't use imaginary numbers with functions, okay? They're not yeah, for the purposes of this lesson, for domain restrictions, we don't want negatives under even roots, okay? Yeah. All right, and another thing we're going to put over here is, oops, that was bad, is must be in the domain of f, g, and h. Okay, so basically if it's the domain of h of x, the x value needs to work for f, g, and h. It can't just work for one of them or a couple of them. It has to work for all of them. Okay? All right, so let's go ahead and do a couple examples now. So we have f of x equals -2 times x to the 1/2 power. All right, well, I'm going to rewrite this with a radical in radical notation because it's going to help us see what we have here. So what's x to the 1/2 power? Well, that's going to be the square root of x, right? Okay. So what's the domain here? So remember, domain, we can't have a denominator equal to 0. Well, that's okay. We don't have a denominator here. Do we have an even root and have an x underneath there? We do. So the domain, we're going to put a capital D here, is it can be all real numbers, all reals is what we're going to put here, all reals, but and then the symbol we use is kind of this double R like this. That's all reals, except we can't have a negative under the radical, so except negatives. Okay, because if we had a negative under the radical there, it's going to give us an error in this function. Okay, so another way to say that is x is greater than or equal to 0. So this is our domain, all reals except negatives, or all reals for x is greater than or equal to 0. Because if it was less than or equal to, if it was less than 0, that'd be negative numbers. Okay. All right. Let's do a couple more. All right, number 2, we have f of x equals 9 times x to the 1/3 minus 5. Let's rewrite this in radical notation. So we have f of x equals 9, and then the x to the 1/3 is the cube root of x minus 5. So what is the domain? What can the domain be? Well, the only problem we have here is we have a radical, but it's an odd or root, so that's actually going to be fine. So the domain, this means we can plug in any number we want for x, and basically what that means is we're going to put all reals. All real numbers will work, or the double R is what I'm going to use from now on probably, okay? So the domain is all real numbers. You can plug in any value you want for x and you won't have any issues, is what that means. All right, next one. We have f of x equals x to the negative 1. Let's rewrite that. Well, to negative 1 power, we put it over 1, move negatives to the bottom, right? Or flip them vertically, so we're going to have 1 over x. Okay. So in this case, we have a denominator here, so we're literally going to take the domain's going to be all reals again, but x cannot equal, in this case, it literally is just x cannot equal 0, because the bottom is, if we take x and set it not equal to 0, there's nothing to solve here. It's literally just x cannot equal 0. And there's our answer. Okay. All right, now we're going to be doing a combination. We're going to be doing an operation, and then we're going to be finding the domain. So in this case, we have f of x equals 5x to the 1/2, and g of x equals negative 9x to the 1/2. And we are adding them. So let's go ahead and add them first. So f of x is 5, and it's going to be square root. Actually, let's write h of x here. H of x equals f of x, which is 5 times the square root of x. Plus negative 9 square root of x, right? That's f of x plus g of x. Well, what's that going to be? Well, h of x is going to equal 5 minus 9. It's like these are like terms here. It's like 5x minus 9x is going to be negative 4 square root of x. All right. In this case, we have so what are our possible domain here? Our domain, we can't have a negative under an even radical here, so it's going to be, x has to be greater than or equal to 0, no negatives. And there's our domain, and there's our answer. Why don't you see if you can try number 2 on your own now? Give it a try. All right, now we're doing f of x minus g of x, so h of x is going to equal 5 square root of x minus, and in this case it's negative 9 square root of x, so it's minus and negative is the same thing as plus a positive, chop chop. So h of x is going to equal 5 plus 9 is 14. We have 14 square root of x. And the domain, we have a radical here. We can't have square root negatives under the radical, so it's going to be x has to be greater than or equal to 0. Those are the numbers that will work in this function and give us an actual result and not give us a wonky, weird thing. Okay? All right. Got a few more examples to try here. All right, we have f of x equals 3x plus 7 and g of x equals x plus 1. Perform the indicated operation and state the domain. So we're multiplying f of x times g of x, so h of x is going to equal, f of x in this case is 3x plus 7, and g of x is x plus 1. So if we FOIL that or distribute that, we're going to get 3x squared. I'm going to skip some steps here because we should know how to distribute nicely. Plus 10x plus 7. So this is just if you do the the loops here and do the FOIL. So what's the domain? The domain in this case, we have no denominators and we have no radicals, so the domain is going to be all real numbers. And there's our answer. All right, now we have f of x divided by g of x. That's going to equal h of x is going to equal, in this case we have 3x plus 7 over x plus 1. And the domain in this case, well, we're gonna literally take, we have a denominator, so we're gonna take the denominator x plus 1 and say it cannot equal 0, and then let's solve it here. How do we solve it? Subtract 1 from both sides, so x cannot equal negative 1. So the domain is all reals, except x cannot equal -1. And this is our answer. All right, couple more examples here. We have f of x equals 6 times x to the 1/2 and g of x equals 4 times x to the 1/3. Perform the indicated operation and state the domain. We're doing f of x times g of x, so in this case h of x is going to equal, we're going to multiply that. So in this case I'm not going to do the radicals, I'm going to keep the rational exponents here, because rational exponent powers are nicer to work with. So how do I multiply this here? Well, we have common bases here, so we're going to multiply 6 times 4, which is 24. And then we have x to the, we're multiplying, these are both common bases, these are both x. So we have 1/2, x to the 1/2 times x to the 1/3. We're going to do 1/2 plus 1/3, right? And then 1/2 is 3/6, and 1/3 is 2/6. So we're going to get h of x equals 24 times x to the 5/6. And then we're going to convert it to the radical notation. So we're going to have 24 times x to the 5th, the 6th root of that. All right. So now, again, we have a radical here. We have an even root, so we need to set the what's under the radical, x to the 5th, and say it needs to be greater than or equal to 0. Now, how do I solve for x here? How do I get rid of the x to the 5th? I'm going to do the 5th root on both sides. So we get x is going to be, it's still going to be greater than or equal to, the 5th root of 0 is still just 0. So our domain is going to be x is greater than or equal to 0. So here's our answer, and here's our domain. All right, last example, we have g of, now this time we're doing g of x divided by f of x. That equals h of x. And we're doing, so 4x to the 1/3 divided by 6x to the 1/2. All right. We can reduce the 4 and the 6. 2 goes into 4 twice. 2 goes into 6 3 times. And in this case, we're going to actually, I'm going to do something a little bit tricky here. Instead of dividing and subtracting the exponents, we're going to do something a little bit different. I'm going to rationalize the denominator here. How do I do that? Well, I'm going to multiply top and bottom by what's going to make this bottom exponent a whole number, which is going to be a 2 or more, a multiple of 2, or 2 or a multiple of 2. So I'm going to multiply this by x to the 1/2. Because that's going to give me, when I do that, I'm going to get 2x, and then that's also going to be, so we already said that 1/3 plus 1/2 equals 5/6, right? And so we're going to have 2x to the 5/6 divided by 3x. Remember, because when we multiply, we have x to the, what's 1/2 plus 1/2? So that's going to be just x to the first, right? That's why we did that, okay? So now our answer is going to be, we have 2x to the 5/6, which is going to equal 2 times the 6th root of x to the 5th, all over 3x. Okay? And so in this case, we have something under the radical, and we also have a denominator here. So I'm going to set the denominator equal to 0. So 3x cannot equal 0. Divided by 3. X cannot equal 0. And then I'm going to set what's under the radical equal to 0. X to the 5th needs to be greater than or equal to 0, that is. Take the 5th root. So x needs to be greater than or equal to 0. So our domain is going to be, and in this case, let's think this through a little bit. So if it can't be equal to 0, but it needs to be greater than or equal to 0, well, all we have to do now is we're going to say the domain, what encompasses both this and this is just x is greater than 0. Because not equal to, because equal to is not part of it. So there's our answer right there. All right, so hopefully you've gotten some practice with operations of functions and with domain restrictions. Thank you for watching. Have a great day. We will talk soon.